Imagine a world where we could map, I mean, every single inch of our planet, basically in near real time, or run an entire cutting-edge science lab instantly, just using AI.
Yeah, it sounds like something straight out of science fiction, doesn't it? But,
Yeah.
pieces of that future, they're not just concepts anymore. They're actually here. They're
Oh.
actively reshaping how we see the Earth and just speeding up discovery like crazy.
We're about to take a deep dive into exactly how. Welcome to the deep dive. Today, we're unpacking some really, truly groundbreaking developments in AI. We've got this fascinating newsletter in front of us that just landed.
Yeah, it's absolutely packed, really dense. We'll kick off exploring Google's new planetary co-pilot, AlphaEarth foundations. Honestly, it's kind of astonishing stuff. Then we'll zoom out a bit, look at a whole range of exciting new AI tools that are transforming industries like right now.
And then finally, we'll shift our focus to something that, well, it genuinely bends the mind a little. Virtual AI scientists. Yes, you heard that correctly. So our mission today is to help you get a handle on this, gain knowledge quickly, maybe spot those key aha moments, and hopefully avoid feeling just, overwhelmed by how fast everything's moving.
Exactly. We want to help you understand not just what's happening, but maybe why it matters, what it could mean for you down the line.
Oh.
Okay, so let's unpack this.
Right, let's begin with Google DeepMind's AlphaEarth foundations. This system is already being called a planetary co-pilot for Earth data. What, in your view, is the real core innovation here? What's the big deal?
Well, what's truly fascinating, I think, is its approach to just handling immense data, like mind-boggling amounts. So instead of using raw pixel-by-pixel satellite images, which are huge files, AlphaEarth compresses petabytes, and that's, thousands of terabytes of this Earth observation data. It compresses it into something they call embedding fields. Think of these as like tiny, super efficient, searchable summaries for every little 10 by 10 meter patch of the Earth's surface.
10 by 10 meters.
Yeah, and the key thing is they're generated in near real time. It's constantly updating.
Okay, that sounds like an incredible leap in just pure efficiency. So when we talk about performance, what kind of impact are we actually seeing? What does this new architecture deliver?
Oh, it's profoundly faster and significantly cheaper to run. The system cuts storage needs by, get this, 16 times. 16, which is just critical when you're dealing with planetary scale information. It also reduces error rates by about 24% compared to the older, more traditional models.
24%, wow.
Yeah. To put it in perspective, we're talking about generating and making available like 1.4 trillion of these embedding footprints every single year. That's like a new snapshot of the Earth's surface, changing, roughly every couple of seconds. It's wild.
Wow, okay, so this isn't just like a research paper or some theoretical concept. It's live right now,
Yeah.
integrated into Google Earth Engine, which, a lot of people already use. Can you give us maybe a few concrete examples? Like, where is this being used in the real world?
Oh, absolutely. There are plenty of applications already rolling out, and they're impacting some really critical environmental work. For instance, Mapiomas down in Brazil, they're actively using AlphaEarth foundations right now. They're monitoring Amazon deforestation in near real time, which gives them crucial data for conservation efforts. Then there's the Global Ecosystems Atlas. They're leveraging it to map regions that were previously uncharted, really, like vast shrublands, remote deserts. It helps us understand global biodiversity better.
Yeah.
And it even outperformed other systems in these things called evapotranspiration tests.
Okay, what's that exactly?
That's basically measuring how water moves through ecosystems. Evaporation, plant transpiration. It's super vital for understanding climate cycles, planning agriculture, predicting droughts, that kind of thing.
Right, right. So it sounds like this makes that kind of planet-scale intelligence much more accessible. It's moving beyond just the big players, like NASA or other national space agencies. What's the bigger picture here? What does it mean that Google is building something like this?
Well, if we connect this to that bigger picture, Google is, essentially building an operating system for Earth. Just imagine, like a single dynamic platform where all this planetary data, weather patterns, deforestation rates, water cycles, you name it, isn't just collected, but it's processed, analyzed, and then made accessible for pretty much anyone to build applications on top of it.
Yeah.
Kind of like how an OS lets software run on your computer, right?
Okay, yeah. An OS for Earth.
And it's also a huge win for AI privacy design, which is really important. Because instead of analyzing, say, sensitive raw images directly, AlphaEarth works with these anonymized embedding fields. So you get the critical data insights without compromising individual privacy or specific location privacy. That's a really critical step for, responsible AI deployment, building trust.
Right, and if you're maybe OpenAI, well, perhaps you'd better move fast on this. Google seems to have taken a big lead on this kind of planetary data infrastructure.
Seems that way.
So if this makes planet-scale data so much more accessible, what's the biggest shift this brings, say, for smaller organizations or even individual users?
I'd say it really democratizes global mapping. It's not just for the big labs anymore. It's potentially for everyone.
Okay, so we've seen how AI is giving us this unprecedented new way to see and understand the whole planet with AlphaEarth. That's the big picture, the macro view. But AI is also revolutionizing things at a much smaller scale, right? Individual tasks, specific industries. Let's pivot now to that broader AI landscape. What new tools or trends have kind of jumped out at you recently?
Yeah, it's been a real flurry lately. So many developments.
Yeah.
For instance, XAI, Elon Musk's company, they just opened a waitlist for Imagine. It's their new image and video generation feature.
Yeah.
And what's cool is it apparently includes audio capabilities too, hinting at that multimodal creation future.
Image, video, and audio.
Right. Then there's Ideogram. They released something called Character. It makes it super easy to just swap faces or specific characters into generated images. You can see how that has huge implications for creative industries, right? Marketing, digital art, maybe even entertainment.
Definitely. And I saw something, too, about specialized AI agents, almost like virtual employees. Can you tell me more about that?
Yeah. Exactly. That's a really significant trend we're seeing emerge. There's this new open source repository out there showcasing like 40 specialized Claude agents. Yeah. And each one is designed to streamline very specific business functions. They can even sort of mimic an entire workforce, handling stuff from customer service bots to complex data analysis. The potential there to automate tasks is just enormous. Could free up human teams for more, complex creative thinking. And honestly, I still wrestle with prompt draft myself sometimes. Yeah. You know that thing where your AI's answers start to subtly change or degrade over time, even if you get the same input? It makes consistency a real headache. Yeah. So these highly specialized purpose-built tools, they're particularly interesting because they aim to get rid of that variability, make things more reliable.
That's wild to think about, an entire virtual workforce. And then there's this thing called Showrunner. It's been described as the Netflix of AI for film. What exactly does that do?
Yeah, Showrunner is pretty remarkable, especially for creative professionals. Film, video, it lets you take existing film scenes and essentially clone them. You can replace actors with AI-generated ones. You can control their acting styles, their expressions, and even precisely copy the whole cinematic look, the lighting, the framing from a reference scene.
Wow.
It's kind of like having an entire production studio just sitting on your desktop. It makes professional quality video creation way more accessible, potentially, and speeds up iteration like crazy. It's pretty incredible for creative work.
Beyond these really fascinating individual tools, what about the big industry movements, the strategic plays? It feels like a high-stakes chess game sometimes out there.
It certainly does. Huge investments happening. So on the investment front, Microsoft is reportedly spending a record like $30 billion this quarter on AI investments. Just shows their massive commitment.
$30 billion in one quarter.
No. Yep. And then there's Groq, a relatively new AI chip startup. They're in the process of raising $600 million. Their goal is to directly challenge Nvidia's dominance in the AI hardware market with their LPU chip architecture. So competition heating up there. And on the more practical consumer side, Google and YouTube, they're now using AI for age checks on user accounts. Just a straightforward application for safety and compliance.
Okay. And what about politically? Or strategically? Any interesting moves from the big tech players regarding, say, regulation or how they plan to control this tech?
Definitely some maneuvering there. Google, for example, publicly stated it will sign the EU's voluntary AI code of practice. So that indicates, a willingness to align with European regulatory thinking. Meta, on the other hand, stated they would not sign it. So signaling maybe a different approach, maybe prioritizing open source development differently. Mark Zuckerberg also hinted that Meta won't open source all of its most advanced superintelligence AI models down the road, perhaps learning from past releases. Plus, Microsoft secured this really interesting OpenAI access deal. It basically ensures that they'll have access to OpenAI's models even after AGI, artificial general intelligence, is potentially achieved. That's a huge strategic hedge for them.
Right. Guarantees access no matter what. So with all these rapid developments, specialized agents, massive investments, strategic corporate moves, what's the core overarching trend here? What's the one-liner?
I'd say AI is just expanding rapidly, embedding itself into basically every industry. It's driving both huge innovation and really intense competition.
Okay, so we've covered how AI is mapping the planet with this incredible new detail, and how it's sparking this explosion of new tools across all sorts of industries. Now, let's talk about something that kind of unites these capabilities in a really profound way. Virtual AI scientists. Stanford University and the Chan Zuckerberg BioHub, they just launched a system that acts like an entire AI research lab. This is where it gets really interesting, I think.
It truly is. Yeah, this is mind-bending stuff. Their setup isn't just like one AI tool. It's a whole ecosystem. It includes an AI principal investigator that's basically the lead scientist making the calls. It has specialized AI agents acting as the researchers doing the work. And get this, they even have digital lab meetings that literally finish in seconds. Just cuts out all that administrative time, discussion overhead.
Meetings in seconds.
Yeah, it's a real glimpse into an entirely new way of doing scientific discovery, a different paradigm.
Okay, but what have these virtual scientists actually discovered? Are there tangible results from this purely virtual process, or is it still theoretical?
No, the results are concrete and pretty impactful already. They've successfully designed 92 distinct COVID nanobody designs. Now, nanobodies, think of them as like tiny, really effective antibodies. They're much smaller, more stable than conventional ones, makes them easier to work with, potentially more potent against diseases.
Okay, 92 designs.
Right, and out of those 92 designs generated by the AI system, 2 have already shown success in actual real-world lab testing, which is a remarkable outcome, frankly, for an entirely virtual process. Really shows AI's power to accelerate biomedical research directly.
That's astonishing. How does this virtual lab actually function, though? What are the mechanics behind it? How does it generate these specific testable breakthroughs?
So the AI principal investigator, the PI, is kind of the orchestrator. It identifies the research problem, then it forms task-specific agent teams. It assigns specialized roles to other AI models, like data analyst or experiment designer. These agents then run these rigorous internal debates, almost like human scientists arguing over data to refine hypotheses and design experiments. And they even automatically call on external specialized tools when needed, like AlphaFold, Google DeepMind's system for predicting protein structures.
Right, yeah.
They call on tools like that all by themselves, integrate that complex data seamlessly. They basically operate autonomously through the whole research cycle, from hypothesis all the way to experimental design.
This raises a really important question then. Why does this matter so profoundly for the future of science? What core bottlenecks does it actually address?
Well, think about traditional science. Most of it is inherently slow, right? It's often blocked by endless meetings, coordinating schedules. It's constrained by budgets, funding cycles, and frequently limited by expert bottlenecks. You need that one specific specialist who's always swamped.
Yeah.
These AI agents, they just skip all that. They don't get tired. They don't need weekends off. They certainly don't care if a lab is short-staffed or someone's on vacation. And maybe crucially, they're transparent. You can literally watch their entire reasoning process unfold, step by step. That gives you an unprecedented level of auditability. You can see how they reached a conclusion.
Whoa. Seriously, imagine scaling this, solving problems at that kind of speed. Like running a billion queries simultaneously to find a cure or some new material. It's staggering.
Yeah.
What are the current limitations, though? It sounds almost too good to be true. Where does it fall short right now?
Yeah, it's definitely not perfect yet. We're still in the early days here. Really complex, long-term studies that require, deep, nuanced, contextual understanding over years. That's still hard. Or those genuinely creative leaps, the kind that involve really abstract conceptual breakthroughs. That still largely seems to need human intuition, human insight. But if this approach scales and improves at the rate it seems to be trending, well, the next major scientific breakthrough may be a cure for a really challenging disease or a solution to a complex environmental problem. It might very well come from what essentially looks like a Slack thread between 4 bots and, a protein structure tool like AlphaFold.
So does this mean human scientists are, on a path to becoming obsolete? Is that the trajectory?
Not yet, I don't think so. Humans are still absolutely crucial for that complex creativity, for asking the right questions, for guiding the big picture strategy. Mid-roll sponsor Reed. So yeah, we've covered some truly profound advancements today, haven't we? I mean, from Google's AlphaEarth mapping basically our entire planet in incredible detail, near real time, to just this burst of innovative new AI tools that are fundamentally changing how we work, how we create, how businesses even operate day to day.
Yeah, and then that mind-bending idea of virtual AI scientists just autonomously conducting research and getting real-world breakthroughs like with those COVID nanobodies. It really shows, I think, that AI isn't just assisting us anymore. It's rapidly becoming a genuine collaborative partner, maybe even a primary driver in the actual process of human discovery itself.
Exactly. What's truly fascinating here, I find, is just how AI is accelerating our basic fundamental capacity, our capacity to understand and interact with the incredibly complex world around us. It feels like we're stacking Lego blocks of data and insight, but at an exponential rate, building these knowledge structures way faster than ever before.
We are definitely, undoubtedly, moving into an era where these incredibly complex global problems, things like precise environmental monitoring or accelerating critical disease research, they can now be tackled with just unprecedented speed and scale and efficiency. So, what does this all mean for you listening right now? We are clearly entering an era where these profound capabilities, things once exclusively reserved for, national labs or massive supercomputers, they're rapidly becoming accessible. So the question is, how will you use these powerful new lenses to see the world around you? Or maybe use these incredible new tools to solve the problems that matter most to you?
Yeah, the power of these kinds of deep dives, just getting into this complex, fast-moving information. It's hopefully helping us all keep pace with this really exciting future that's unfolding.
We sincerely hope this deep dive gave you some valuable new insights, maybe sparked a few aha moments along the way. Thank you so much for joining us.
Until next time, keep exploring Outiro Music.